In the previous lecture, we studied about the buoyancy force. So that's the force when you put something on the in the liquid, you experience an upward force. We discussed an example of a bottle, and also we discussed an example of nail and the cork, right? So here we will start discussing or understanding Archimedes principle, and that is basically going to give you an understanding how to calculate that mysterious buoyancy force. What are the factors which is affecting it, and why the nail is sinking, why the cork is not sinking, why it takes so much effort to sink that water bottle in the bucket. Okay, so to do that, I'm going to do a little activity here, and that will give us our final piece of the puzzle which is affecting this buoyancy force. All right, so let's consider we have a rubber string, and on the bottom of it, it is tied to a stone. Okay, if the mass of the stone is 1 kg, then the weight of the stone is going to be 1 kg multiplied by 9.8 meter per second square. That is going to be 9.8 Newton. All right, so that's going to be the weight of the stone. Now this is all connected to the top. So this is a rubber string. Because of the weight of the stone, this string would be tight, and let's say this is extended. So extended length of the string is about, let's say, 100 centimeter. Now imagine that you have a bucket of water. Okay, it's filled with water. What we are doing now, we are slowly moving this surface down, this hinge point. Okay, now what you will find, this length, this length of this string, which initially was 100 centimeter, and let's say once we start moving this down, stone is about half immersed in the water. Okay, so initially stone is above water level. When I say above water level, I mean this level. Okay, now what you will find as you are start bringing this surface down, stone will start immersing in the water. The length of the string will go down. So I'm gonna take some examples here. Let's say length of the string become 80 centimeter when it is half immersed in water, and the length of the string is like 60 centimeter when it is fully immersed. Okay. All right, now, and the last thing, this is important, this length will remain 60 centimeter even though I put the stone all the way to the down. Okay, it doesn't matter if the stone is here or here or here. The length of the string does not change. Just try to understand here that the length of the string is dependent upon the weight. Initially, when there was no water, when the stone was just stretching the string, then the length of the string was 100 centimeter, and it's all because of the weight of the stone, because that's what pulling the string down, right? The moment you start bringing the water into the system, you start see the length of the string starts changing. We know weight is not changing, right? Because the mass is constant, gravity is constant, so weight is always 9.8 Newton. Then why the length is decreasing as the stone is going inside the water? And we know this is because of that mysterious buoyancy force. So we can say the length is proportional to the weight minus that buoyancy force. So that thing is clear. Okay, now, so second observation we can make from this activity is that buoyancy force is dependent upon how much of the stone is inside the water. Okay, When it is half immersed, the length was 80. When it is fully immersed, the length is 60. After that, it stops changing. So the buoyancy of the force is dependent upon the volume, okay, of stone immersed. Okay, so these are points I would like to guys to think about. Length is initially was proportional to the weight, but after a while, when buoyancy starts coming into play, buoyancy has a negative impact on the length, and the buoyancy force, which is the upward force acting on the stone, is dependent upon how much of the volume of the stone is immersed inside water. Now the last point, which we didn't discuss so far, is what if I change the water, this fluid in this bucket from water to oil, or to some highly viscous fluid. Okay, so what happens when we start changing the characteristic of the liquid? So answer to all these questions are actually given by Archimedes principle, and that's why we are discussing here. Buoyancy force, what are the factors it is dependent upon? All this would be discussed in the Archimedes principle. So what is Archimedes principle? Let's write it down. So Archimedes principle is pretty simple. Now it states that when a body is immersed. Now when a body is immersed, now it could be half or fully immersed, or like it could be a certain percentage of its volume which is immersed in the fluid. It experiences a upward force. Now this is that buoyancy force we discussed about, the mysterious buoyancy force, and we talked about different properties or the factors which is dependent upon through various activities we performed. Okay, it experiences the upward force, that is, now this is important, that upward force is equal to the weight. Now it's not the weight of the object, it is the weight of the fluid. Weight of the fluid displaced by it. Okay, very important stuff. So if in a bucket filled with water, I put a block of volume V, then the upward force, the buoyancy force acting on that object would be weight of water, because it is water here, of volume V, and this is when the block is completely immersed in the water. If I'm only half immersed, then it would be whatever the volume of the water displaced by the object. Okay, so very important. So all the activities we have discussed. Now again, revise those activities based on this definition. Okay, I'm going to give one walk through one activity, that is the stone example we discussed. This is my bucket and it is filled with water. Okay, if my stone is here, the buoyancy force is 0 because it has not displaced any water, because it's not even inside the water. When the stone is here, it has displaced some of the water, because once you put the stone, you will see, because you will find that your volume or the level of the water in the bucket will go up, because this amount of water is displaced by the stone, so it's gonna rise up. Now once the stone is completely immersed, okay, Now this time the level will rise up more because now stone is inside, and the buoyancy force acting on the stone is equal to the volume. So the buoyancy force, this B, is equal to volume of the stone. This is total volume of the stone into density of the liquid. So this would be whatever this liquid is. I'm going to use L, so it could be water, oil, whatever. And so this would be mass, right? Density into volume, and then you multiply this by gravity. That would be weight of the liquid, and this is going to act upwards direction. I hope this is clear. Now, let me share one story with you, a very interesting story about Archimedes. Now, Archimedes was a Greek scientist. He was a mathematician, okay? And this is, I think it is true, might be, but you might have heard the word eureka. So this story will tell you from where the word eureka was and why it became so famous. So one day the king asked, king had a crown with gold. Now he was a little skeptical of the quality of the gold in that crown, so he asked Archimedes to figure out how pure or how much of the crown is made of gold. Okay, Archimedes was a little troubled because he didn't know how to calculate that, and he started thinking, he started panicking. But as a scientist, he started thinking about how can he calculate that. So one day Archimedes was taking a bath in his bathroom in a bathtub, okay, and when he stepped inside the bathtub, he saw the water from the bathtub spill outwards. And that moment he realized the solution to his problem, and he immediately stepped out of the bathtub. He was very excited, and shouting the word eureka, eureka, and then start running naked. Now let's try to understand what was that realization which Archimedes was very excited about. Okay, so let's consider that you have two crowns. Okay, crown 1 and then crown 2. Okay, so crown 1 is pure gold, and this one is gold plus silver, and that's what Archimedes needs to find out, right? Whether how much of the impurity is in the gold crown. So let's consider silver as the impurity. We know that the density of the gold is higher than the silver. So the density of a crown 1 is higher than density of the crown 2. All right. Now, if we have both the crowns of the same weight, 100 Newton or 100 Newton, or you can say both are of the same mass, then the volume of the crown would be higher in the crown 2. Why is that? Because weight is mass into gravity, right? And mass is density. I'm going to use this symbol for density into volume into gravity. Okay, so if the weight is same, okay, and gravity is of course not changing between the two crowns, if the density is higher, the volume would be lower. Okay, it would be inversely proportional to the density. Okay, so now this was basically the answer. What only the thing which Archimedes has to do is to compare how much of the volume of the water crown 2 will displace compared to crown 1, and that will tell him the amount of impurity present in the crown. So that was the thing which Archimedes realized in that when he was stepping into the bathtub and saw the spilling of the water. One of the great moments in the history of the physics. All right. So now Archimedes principle, I would like you guys to just remember it. Is very, very important. It will help you a lot in your solving many problems and also understanding your lot of routine or daily activities It has huge applications. It is used in designing the ships and submarines. It is also used in lactometers, which is used to determine the purity of the sample of milk, and also for hydrometers. Okay, and that kind of instrument is used for calculating the density of the liquids. All right, so good applications. One more time, Archimedes principle states that when a body is immersed, it experiences an upward force that is equal to the weight of the liquid displaced by it. Okay, remember this, watch this video a few more times. I think that should make you guys understand it clearly. And next time we will discuss about relative density.